Group 16 elements: oxygen, sulfur, selenium, tellurium, and polonium. These are considered to be group 16 elements in the periodic table, and they are known as chalcogens. Now, why they are known as chalcogens? Chalcogens means ore making. So, as they are ore making, it is derived from a Greek word brass and associated with sulfur. It also means they are forming ore in the earth crust, and this is the reason they are known as chalcogens. So here the speciality about this group that most of the elements are found as minerals in the earth crust. Now coming to the occurrence in atmosphere, all these elements occur in free as well as in combined state. In free state, oxygen forms the abundance air that we all know, 24% approximate by volume in the air, and in earth also oxygen is present 46.6% by mass. In abundance it is present in earth crust. Now coming to sulfur, sulfur is also present in earth crust in free state, as well as it also exists in combined state in sulfates, as for example gypsum, calcium sulfate hydrate, Epsom salt, magnesium sulfate, bride, barium sulfate, and in the form of various sulfide ores like galena, zinc, lead, and copper pyrites. Sulfur is also forming hydrogen sulfide in volcanoes, and it's also a naturally occurring source. Then rest of the shells like egg, proteins, garlic, onion, mustard, hair, roll also contain sulfur. So here also comes an important thing, that while cutting onion we get tears. Why we get tears? Because of the presence of sulfur. The remaining elements like selenium and tellurium, they are found in the form of metal selenides and tellurides in the earth crust. So they are, along with sulfide ores, they are forming in the earth crust. Polonium being radioactive in nature, so it is found in traces in the earth crust. Now these were the occurrence of the group 16. Now let us come to the properties, physical and chemical properties of group 16 elements. Now the very first thing that we are going to discuss about group 16 is electronic configuration, and the general electronic configuration of group 16 is Ns2Np4. That resembles that it has 4 electrons in the outermost shell, means in group S and P they are having total 6 electrons, and in the outermost subshell P 4 electrons. So in total they have 6 electrons in the outermost valence shell. Now coming to the next, Ns2 and Np4 means, for example, oxygen, atomic number 8, 1s2, 2s2, 2p4. So here the configuration of oxygen is 2s2, 2p4. In the same way, sulfur 3s2, 3p4. Then coming to the next element of the sulfur in group 16, that is selenium, that will be 4s2, 4p4, and in the same manner down the group 1 shell increases, and here is the valence shell Ns2 Np4. Only the value of N changes, but rest the number of electron in S and P in the outermost shell will remain same, that is Ns2 and Np4. Now coming to the another category, atomic and ionic radii. Atomic and ionic radii, what is the meaning? We have already discussed in the previous group, the distance from the nucleus to the outermost shell where the electrons are present. Here down the group we are going to observe that number of shell increases. So atomic and ionic radii down the group increases, and oxygen considered to be exceptionally small in the entire group. The next property that we are going to discuss in group 16 is ionization enthalpy. Ionization enthalpy means energy required to remove the outermost shell electron. It is very high in comparison to group 15 because of higher nuclear charge, but slightly the lower ionization enthalpy is there in comparison to group 15, means though the nuclear charge is high in comparison to group 16. So nuclear charge is high, in group 16, but in comparison to group 15, the nuclear charge of group 16 is also high. So it should have high ionization enthalpy, but it is having a low ionization enthalpy. So it is having a low ionization enthalpy. Reason that group 15 is having a stable configuration, that half filled p orbitals, and group 16 is having incomplete. So group 16 is having slightly lower ionization enthalpy than 15. Now coming to the next property, electron gain enthalpy. Electron gain enthalpy is the amount of energy released when an atom accepts an electron. It depends on electronegativity. Down the group, electronegativity decreases, so electron gain enthalpy should also decrease down the group. But oxygen is having less electron gain enthalpy in comparison to sulfur. Reason, oxygen is small in size and facing interelectronic repulsion for the incoming electron. This is a reason its electron gain enthalpy is slightly less than sulfur, and sulfur being more stable, having no interelectronic repulsion, so its electron gain enthalpy is higher than oxygen. Rest from selenium to polonium, gain enthalpy decreases due to increase in size. Coming to electronegativity, electronegativity follows the simple trend that down the group, electronegativity decreases due to increase in size, and oxygen becomes the most electronegative element of this group. And after fluorine, oxygen is the second most electronegative atom. Down the group, electronegativity decreases. That's why metallic character increases down the group.